Hey everybody, and welcome to another Learning Statistics with Jamovi video. In this video, we are going to talk about how to do correlations. And then in the next video, I will talk to you about how to get scatter plots in addition to the correlation matrix. So stay tuned for that pair of videos, this video and next video. Okay, so let's open up some data. Before we do that, like always, I like to show y'all that we are using 2.2.5 version, which is currently at the time of recording the most up-to-date version of Jamovi. All right, so data. So for all of you to be able to follow along, what I want to do is simply use the base Jamovi data library data, okay? So in other words, what I want to do is I want to go to the hamburger menu over here and click on Open and go to Data Library. And you can ignore all of these different folders that I have for all of these modules that I installed. And all I want to do is open the Big Five, this Dolan et al. Big Five dataset with 500 cases in it. This comes with the base installation of Jamovi. So you should have these 4 CSV files in order to open. Okay, so we can open that and you should be able to follow along with me as we do this. Okay, so our data here is pretty self-explanatory. We have, like I said, 500 cases of data, a scalar data that has what I would imagine is actually, since we have decimal points here, is averages for a person. So on the neuroticism scale, they averaged 2.479 on the items that were asking questions about neuroticism and so on and so forth. So we have average scores here. They're being read as scalar variables. If you're not familiar with the Big Five, the Big Five is 5 major personality traits, and they are, so sometimes you'll see this as canoe, sometimes you'll see this as ocean. The idea is that the 5 traits that everyone has in their personalities to varying degrees, these are all continua, so they're all dimensional with highs and lows and anywhere in between, basically. Neuroticism, extroversion, openness, agreeableness, and conscientiousness. And so people have varying degrees of these 5 qualities. So what I want to do is show you how to correlate them together. We may have done a little bit of this in a previous video, but here I want to focus on actually looking at the output for correlations. So to do correlations in Jamovi, you'll find it under the regression menu here. So you click on that, and it's the first option, correlation matrix. Okay, so we're going to click on that, and it's going to open up the correlation matrix. And by default, you have a correlation matrix presented here, and it's going to give you Pearson's R, and it's going to report the significant relationships, and it will, you can flag those correlations if you'd like, but for here, it's going to give us the p-value. I kind of wish that they just named this report p-value instead of reporting significance, or if anything, report significance level. But significance by itself really just kind of makes p-values seem like it's the meaningful end-all be-all of a correlation, and that's not true because correlations and their p-values are heavily dependent on sample size. And so you're going to see some small correlations that are going to be significant at the p is less than 0.05 level that are kind of small when you compare it to, the 0.1, 0.3, 0.5 Cohen, the Cohen's conventions for describing. So 0.1 is a small correlation, 0.3 is a medium or moderate correlation, and 0.5 is a big or a strong, large or strong correlation. I forgot to say weak for the 0.01. Okay, so what we're going to do here is we're going to grab all of ours, and how I selected them is I clicked on neuroticism and I held shift down to select all of them. You can also hold command or control, depending on if you're a Mac or a PC, to click on each of them in kind while keeping the other one selected. So that's a fun way to do it. But if you want to select all in a list, you hold shift down, click the beginning, click the end, and they all go over there. And here I clicked it. So first things first, we want to make sure that we have the right correlation coefficients, and that's what happens. Now, this correlation matrix that I've shown you is an APA-style correlation matrix. And the idea here is that it's only showing you the bottom of the diagonal, because the diagonal itself is the autocorrelation, neuroticism correlated with neuroticism. That would be 1, of course, and the p-value would be 0, which is impossible. And then they do not put the reciprocal, which is the around the mirror here. These would be the exact same values. You just flip these over, and one thing you can do is look at this one, negative 0.368. That would go up in this corner over here because it's neuroticism by conscientiousness, and that would be the same going across the row. So they clean it up for you and pretty much give you an APA style correlation matrix, which is great because if you're doing a correlation matrix with like 20 different, I hope you don't do 20 different variables, but if you were doing something larger than 5 here, you would need a correlation matrix as a table, which would be really helpful. We can also get Spearman, which is a non-parametric test. You can get Spearman's rho, and it will give you a p-value for that one as well. For this particular set of data, Spearman's rho does not make sense because we don't we don't violate any of the assumptions with Pearson's R, so we don't need to go non-parametric here. You can also get Kendall's tau B, which again is another non-parametric test, which in this case we don't. But I clicked them because I wanted to show you how they look on the matrix. So how they get put on the matrix is they get to put the statistic, then the p-value, statistic, then the p-value, statistic, then the p-value. So it gets a little bit hard to read. I mean, unfortunately, this is the best way to do it because at least you keep, the statistic with its p-value. I don't know if there's a better way to do this. Probably is the best way to do this, to be honest with you. We can change our hypothesis and whether or not flagging significant correlations at various levels makes sense. And so first and foremost, we can say that our null does not equal, or our two values are correlated with each other as opposed to not correlated, which is our null hypothesis. Null hypothesis is that the variables are not correlated with each other. So this would be non-directional. And then we have two options for a directional test, which would put all of our alpha at this point, 0.05, because that's the default, all onto one side as opposed to both tails of the correlation distribution, R distribution. So you can change that, and what ends up happening is not very much because this radio button selection is only useful if you have flag significant correlations checked. So, and in most cases, you're probably only going to do correlated as the hypothesis because correlations are bidirectional, and it just makes sense that you would leave them this way unless you had some previous theory to think otherwise. But, two-tailed correlations are better, in my opinion, because they're more conservative. We split 0.05 in half, and we're testing both tails of the distribution. I think it's better that way. I'm going to go ahead and uncheck Spearman and Kendall's tau before we look at some of these additional options. Okay, so I've been mentioning flag significant correlations quite a bit, and all this does is add a note here at the bottom for each level of asterisk, and so this is done by convention. A single asterisk is p is less than 0.05, double asterisk p is less than 0.01, triple asterisk p is less than 0.001. So there is the flaggings there, and so you can immediately pick those out. And like I said, some of these, because we have 500 cases, some of these smaller, weaker correlations are super significant. So just be aware of that. You can also add n to each row. In certain cases, you might have some missing values, which would change the correlation n. So the n of R basically would change, not degrees of freedom, but the n that is used for R, because it's done as a case-wise deletion. So in each pair, if there is a missing value, then that pair gets deleted from the analysis. And so if you had missing values, those numbers would appear on the bottom here. Again, makes the matrix a little unwieldy. And so I would only recommend showing n if you knew that you were going to have different numbers in each of these matrix cells. Otherwise, you can just say that n was 500. You can also add confidence intervals. Again, it makes the matrix a little bit clunky. What it does is it puts the 95% confidence interval limits, upper and lower, underneath the p-value if you have report significance on, or if you turn that off, it will just give that to you underneath. And so this is a value that is supposed to fit in between these confidence intervals. And you can change the amount of confidence intervals. It just changes the value in the calculation and in the table matrix. So there you go. That's how you do that. And that's how you do correlations in Jamovi. If you have any comments, questions, or suggestions, please leave those down below. Thanks for watching. Toodly-doo.